this time around, let's try to solve for the significant relationship of your independent and dependent variable. First is we will try to solve for the mean again. So this is just a review to what you have learned last time. So sum of this one, then that would be divided by 5 questions. Drag. In our sample this time, we have, in our independent variable, we have 5 indicators. Right here, we have this indicator 1, and this is indicator 2. So that's our sample. Now, right here on this side, on the left side of your spreadsheet, this will be the respondents. So our sample is respondent 1 to respondent 28, but I know for sure that your sample size is 100 plus. So your respondents must be 100 plus or maybe less than 100. So for indicator 2, we will solve for the mean again. So I know for sure that you know how to solve this one, and we will divide by 5. Drag. And same that would be divided by 5. For indicator number 4. So for the dependent variable, we will be solving also the mean for the indicator 1. To be divided by 5. So right here for indicator number 2 of the dependent variable, there are 3 items. So we will divide this by 3 items only. That would be divided by 3. So that's it. So we have solved all the mean for the indicator 1 to 5 for the independent variable, and mean for solve for mean for the indicator 1 and 2 for the dependent variable. Now this time, there are 2 processes on how we will solve for the significant difference. The first process, you will use correlation. What you will do is to add all the mean. These are all the mean for the indicators. So you will add this one. So that would be this one plus this one plus this one. This one right here. Let's add cell. Insert. So equal sign, this one plus this one. And that would be, so that's 25. This would be divided by how many indicators? So that's 5 indicators. So these are now, this is the mean for all the indicators we have. For respondent one, the mean will be 5 for all the indicators. So let's drag this and this one. So these are all the mean for the independent variable for all the indicators from indicator 1 to 5. Then let's try to solve for the mean for the dependent variable. So that's 10. Then we'll try to divide this 1 by 2 because we have 2 indicators for the dependent variable. So that's 5. Let's try this. So these are all the mean for the dependent variable. So what we're going to do is we will use correlation. So this one, then analysis tools, solver, add-ins, that one, how to check, okay. Then we will include this one. We will use data analysis. So on the data analysis, naku siya mapadako. On the data analysis, we have ANOVA single factor, ANOVA two factors with replication, ANOVA's 2 factors without replication. And this time we will be using correlation. This one. So let's try correlation. Okay. So what is right here is the input ranges. So for the input ranges, we will be using this one, all the mean for all the indicators. Let's try to copy na lang. Let's try to copy. Then maybe this side right here. So special, paste special, then values. And this one right here. This is for the dependent variable. Copy, then right here. Paste special, then values. That's it. Just try to remember that this one right here is the independent variable. All the mean for the independent variable on this side right here are for the dependent variable. So let's try to solve. Let's try to solve for the correlation. So we'll use data analysis, then correlation. Try to, for input ranges, here. Okay. And output range right here. Then press OK. So right here, this number right here, this is the result for the correlation of the independent column 1 and column 2 independent and dependent variables. So this is 0.449. So we'll try right here. 0.49 indicates that the correlation the correlation right here, 0.49 right here is a moderately strong correlation, meaning that your independent and dependent variable has a moderately strong correlation. So the second step of solving the significant relationship of the independent and dependent variable is to use the regression analysis. So right here, we use a correlation. So we know the value of correlation. This is 0.49, which indicates that there is a moderately strong correlation. How to solve for regression is, again, we will use a data analysis, then regression, then regression. So for range Y, we will be using the dependent variable. For range X or an input X, we will be using the independent variable. So for Y, right here, Y, then for X, we will be using the independent variable. Then output range only. Then we will do and press OK. Okay. So right here, press OK. So these are now the summary output of our regression analysis. So we will try to check the result of the correlation is 0.49. Right here, the result of the correlation is 0.49, so which is the same. What's the essence of using regression analysis is for us to know the p-value. The p-value is the one that tells us if we will try to accept or we will try to reject our null hypothesis. So we will be using this one, or this one, or this one. So they are all the same, 0.07. So on the significant F, tells about the p-value, and which this value right here is same with this value right here. So again, the p-value is the significance of this p-value is for us to reject or accept the null hypothesis. And since our margin of error is 0.05, our p-value is 0.00, this means that the null hypothesis is rejected. Therefore, there is a significant relationship between the independent and dependent variable, which is 0.09, which will be described as a moderately strong correlation. Para sa tanan nga mga subscriber nga mga Bisaya, kung gusto mo nga binisayaon nato pag-discuss ang research, pwede mo mag-request sa ako ang binisayaon nato pag-discuss ang ato ang research. Please try to message me on the comment box na lang para mahimuan ta mo o discussion nga binisaya para sa tanan parts sa quantitative or qualitative research. So that will be our lesson for today. I'm really hoping that you understand how to solve for the significant for the significant relationship of our independent and dependent variable using correlation and using regression analysis on the add-ins tool pack of the Excel.